Our bottom end is now fully forged, and I hope it will not blow up. Hello guys, and welcome to my YouTube channel again. In this episode, we are gonna assemble the bottom end of our baby Supra.
But how did this engine become like that, red and nice? After I disassembled the engine, I put the engine block in acid for 24 hours at 60 Celsius. This took away all the color, the oil and the rust without destroying the metal. Then I washed it with a pressure washer and blow it very good and mask it ready for paint, because the corrosion starts immediately when you have bare metal. After that, I sprayed some filler to protect it from rusting further away, and after 10 minutes I sprayed it over with a 2-component red matte paint and let it dry overnight. The color name is Cardinal Red and my girlfriend picked it, so we have to like it. And now I really had to put the engine somewhere to work. I could not put it back together on the floor, so I bought this engine stand from Emma. It's very cheap and it will do the job very good. So guys, this is the stative from Emma. It cost only 880 kroner, $80 or something like that, and I think it's gonna be very nice. Another job that we need to do before we put together our engine is the oil pump. When you have a turbo car, oil is going inside the turbo and oil exiting the turbo, and this returns here in the oil pump. Here is all the oil of your engine, and the oil pump is sucking the oil and pressurize it all over the engine. Inside the turbo, back here. But we need a hole. We need to do a hole here in order to have our oil return from the turbo. One job is this that we need to do. We have already cleaned it, and my girlfriend cleaned all the gasket sealer. Now we need to make the hole, weld here, and as you see before, somebody drives somewhere, and this here should be round. But I see that it's crushed inside, so we need to somehow hit it back out and sandblast it, make the hole here for the oil return, and make it ready. We will paint it and make it nice, so this is ready to go back into the engine. This is here guys, welded. It was a little bit difficult to weld all around, so I had to do this piece here, and inside is looking much better actually, but I think this can hold the building, so it will be no problem. Now I'm gonna grind it a little bit, make it nice, and we are gonna paint it. And this is ready. Now let's get to work, because this engine, it ain't gonna build itself.
This bottom end is from the engine that came with the car. It has been driven 190,000 kilometers and it was very, very healthy. When I disassembly and I checked the bearings and the cylinders, it's very, very healthy, everything. So now we have the pistons and the rods, but before we assemble this and we put it in the engine, we have to measure the cylinders and be 100% that the tolerance between the piston and the cylinder bore is going to be what it should be, because if it's too small, it can be a problem. Here, at the piston installation guidelines, it says that for forced induction, we need 0.088 millimeters between the piston and the cylinder bore to be okay. So we are going to measure this, and we are also going to measure if our cylinders has oval, because as the engine is working, it tends to make the circle of the cylinder bore, it tends to make it like oval little bit, how the force is applied when the piston goes down and turns the crankshaft. So we are going to measure, we don't want to have more than 0.03 or 0.04 oval in our cylinders. And we are going to hone also the engine, not to make the bores any bigger, just to prepare the surface to make new lines inside the cylinder. And this is going to help our piston rings to seal better with this. And other than that, if everything is okay, then we will assemble the rods and the pistons, and we will gap the piston rings. We will measure the gap. When you put the piston ring inside the cylinder, there is a gap. This gap, it has to be not too big, because the combustion will leak or the engine will burn oil, and not too small, because when it's too small and the piston ring is like this, when it heats up and it expands, it can touch the two ends together, and it will lift up and it will break the top of the piston here. So we have to put them inside and measure with our filler. And if it's too small, I bought this tool that you can file the piston ring and make the gap a little bit bigger. This is going to take some time, and we have to get started. First, we are going to measure the cylinders and put all the numbers here. We are going to take 3 measurements on top, on the middle, and on the bottom, like this on the cylinder and like this on the cylinder. So it's going to be 6 measurements per cylinder. So first, we are going to put our micrometer at exactly 74 millimeters, because this bore is 74 millimeters. So we put it at 74. Here it is. Then we are going to take our cylinder bore meter, and this is 74, and we have to put our cylinder bore meter inside here and put it so it's 0. So it's exactly 0. And then, now that we know that when it's at exactly 74, it's on 0, when we put it inside the cylinder and we will measure, we will see how much bigger has the cylinder become from the use of the engine. And when we will measure like this, we will see how much oval the cylinder has becoming to be. We will see how much oval is the cylinder. Now I got it right. So let's start measure and write down on our paper. This is all the measurements that I got from the cylinder, guys. Here you can see it's 1, 2, 3, and 4 cylinder. And as you see here, it's like horizontal, it's 74.02, and vertical, it's 74.04. That means that our cylinder has 0.02 oval. and this is acceptable because the biggest stress on the cylinder is on the top, that the combustion and the ignition of our air-fuel mixer, it happens. And as you go lower on the cylinder, you see that the oval is smaller. The biggest was on cylinder number 2, was 0.04, and as you go down it was smaller. Here it's 0.025, and the fourth is 0.03. So this is okay. Now we have to measure our pistons with the micrometer. We will put the cylinder bore meter, so it says we measure this, and then we put it here, so it says 0, and then when you put it inside your cylinder bore, you can see what is the gap between the piston and the cylinder bore. So let's do this now. So Vosner says that our piston is 73.93, and here we are going to measure. We measure at the biggest point of the piston, that is 3 mm before the skirt of the piston finishes. So we put it like this. We take this micrometer easy, and we start to tighten this down, and we move it front and back till there is no gap between these two. We lock the micrometer there, and here the micrometer says that this piston is 71.23 and a half and 41.23. So it says that it's 73 and a half, it's 73.5 plus 43. It means that it's indeed 73.93. So now we take the cylinder bore like this, and we have to adjust it so it's inside here and on 0. So I have to move it a little bit, and this is exactly here. So now what it happens when I put the cylinder bore meter inside the cylinder, here on top, that is the biggest oval of the cylinder, I see the smallest measurement that I take when it's left from the 0 there is the gap that I have between the piston and the cylinder. So here I have it says that we need 0.88, and we have 0.85, I will say. So I think this is good enough. We go more high up on the cylinder, we have 0.91. Lower in the cylinder, we have 0.88. So this is good to go. I think we are exactly on spot. I think I'm very happy. I will check all the pistons with all the cylinders, and we are good to go. Now that I measured all the pistons and all the cylinders, I found out that our piston gap is going to be from 0.07 to 0.010 maximum on the biggest areas that we have the oval, and I think it's okay. It's also the first time I'm doing this thing, and it's going to be a little bit loose, but at least it's not going to need too much braking. We are going to send it straight away. Now we are going to use this honing tool to make new lines inside our cylinders. You see, it's very good. This is just some a little bit of rust that came after I washed and I painted the engine block. Now it's going to be clean, and we're going to measure one last time, and we are ready to make our piston ring gaps. The plan, guys, is that we are going to make new lines on the cylinders with this tool. It's the first time I'm doing this, and we put this here. We will put this oil a little bit. And let's see what we did. Look the old cylinders and look how it's becoming. These lines we need in order to stay oil inside there, and it lubricates our piston ring that is going up and down. I have done this little bit also. And as you see, there is not scuffing marks on the cylinder from the previous use. So I think it's looking very good. I will take all of them, and I will clean the block very, very good. This is how the cylinders look now. I just do it with the finest cutting material that I could use. I don't think it needs more than that, because it was in a very good condition all the way down to the cylinder. It's going very smooth. So guys, this is my last top ring that I have to fix the gap. So what I'm doing right now, I'm taking the rings out of their packet. I put it inside here, but you have to put it nice and flat around the cylinder. So what am I doing? I take the piston ring, I squeeze it in like this. It's in. But as you see, it's not going down straight. So I put two pins on one piston, and what I'm doing, I take it like this, I put it here, and I press it in till these two pins is touching down. Then now it's completely flat inside the cylinder. Then I take this filler. My top ring, I did the math on the Vosner here. It says that the chart below illustrates some typical ring end gap dimensions based on general guidelines. To calculate the ring end gap, multiply the cylinder bore diameter in inches times the end gap mentioned on the chart. So we are here. Forced induction, 0.0055. So I did the math, 2.91 inches equals to 74 millimeter. So this times 0.0055 is 0.016 inches or 0.40 millimeter. So this is my filler here. I don't know if you can focus and see it there. And I take this filler, and if you see, now I have fixed this gap. Is going here exactly. The same on the second one, exactly. The third one is going in. Now the fourth one we have not fixed yet, and if you see, is not going in. So I take it off, easy, so I don't break it, because now I'm doing the video also. And I don't want to break it, it's bad if we break it. Okay, we take it off, we put it here, like this. I take only one side. You don't have to press it a lot, but if I put here, then you take it like this, and you file it. Easy, very easy, because if you remove too much, you cannot put it back. So I do at least 5-6 times every piston ring, so I get it exactly right. Now we will try one more time. You don't want to break it. So you take it, you put it back in with the piston. Nice. Now it's flat and square. You take this filler, and I don't know if you can see there, but it's going in, but it's not going all the way, or it's very, very tight. You see, it's very, very tight. So we will do little bit more and put it back in. And for the second rings, these ones, that is the second ring, the gap has to be 2.91 times 0.0065 is 0.018, 189, like we can say 0.019, that it equals to 0.48 millimeters. So I have to make the gap on the second rings also the same way, and it takes time. So guys, here is everything ready. The second rings didn't need any gapping. There it says that it will need 0.48 millimeter gap, and I put them inside, and it's at 0. The 0.45 is going in, and the 0.50 is going very tight. So I didn't do anything with them. Now I will finally put the rods on the pistons. First I will put the piston on the rod with a pin and these safety clips, and after we are going to put all the rings on the pistons, and then we are ready to put back the crankshaft and everything to assembly with the new bearings here. So guys, now the time that I have been waiting for so long, everything here is clean and it's ready to put back together. Yesterday we put the pistons, we put all together the pistons, we fixed the gaps and we measured the cylinders, and now everything is here. First we will start with the main bearings here. So we have to take this, take our new ACL main bearings, we will put some oil on them and we will put them into place.
Now if you look closely there, you will see that I have made some extra room for the rods. It was not necessary, but it was very, very close, and I wanted to be sure.
Here, this bearing that has the hole, it has to go here, on the block, on the side with the hole. Now we will put the rest of the bearings here. Here this is with the numbers 1, 2, 3, 4, 5, and the direction is to the first cylinder. So we put a little bit of oil here and on the bearing. After that, we have the thrust bearings. These control the movement of the crankshaft. This is also new, and this gap, it has to be is on the middle main bearing, and the gap has to be like this, looking the side of the crankshaft, like that. So two of these, this with this gap here, is going on the middle one, like so. We put a little bit oil. And these two. So now we have to torque them down, and this needs in total 58 Newton meters, but first we are going to tighten them all to 29 and then to 58 with this torque wrench. So we put it at 29 Newton meters. And now the crankshaft is torqued on the bottom end. Now is finally the time to put our pistons in the motor. First, we have to put the bearings on the rods. On the max speeding rods here, it's, every cap is matched to the rod, so you cannot mess it up because it has the same numbers. And you take out this, the bolts from every one. Now that we finished with the bearings, we have to compress the rings and put it inside the cylinder. This arrow is showing the exhaust side, and this is the port for the intake valves. Always the bigger valves is the intake valves, so here it has pockets for the intake valves. And we have to put a lot of oil on the inside this tool. You take this tool, you put the piston inside and you tighten it up, and it compresses the rings, and then you push it inside the cylinder. So now we will put a lot of oil here. So now it's very important that these rings, the gap of the rings, is not in the same exactly side. So we will put the first ring on top, the second ring on the bottom, and these rings here, that is the oil rings, we will turn it. So one, the gap is on the left side, and the other one should be on the right side. And now one on top, one on the bottom, and the other two is left and right. So we will take this tool. We need to make it bigger. And we have to do this 4 more times. So now, guys, that all 4 pistons are inside the block. I was very careful not to break some piston ring. I tried my best. We will find out soon. And here, if you see the rod, the bearing cap has this number 289, and this rod is the 0289. So you have to align it. We put it like this. And also here, this teeth, it has to meet the other one. After everything is in place here, we will torque it now, and we will do, it's going to be 40 Newton meters. First we are going to do 20, 20, and then we're going to do 40 and 40. So we start at 20 Newton meters. I think this is amazing. Our bottom end is now fully forged, and I hope it will not blow up.
In order to keep all our new internals well lubricated, we had to put a new oil pump. So that's what I did. New O-ring, oil pump and crankshaft seals. I had to take the engine off the stative in order to put the seal on the transmission side, and then put it back on again. Then I placed on the block the oil pickup tube, and finally we put the gasket maker on our oil pan and we torque it on the block. I'm not a professional engine builder, and I'm doing this job in the most cheap and DIY way that I could possibly do it. I really enjoy this build, and I'm learning a lot on the way. And if it blows up, at least I made it myself, and I will learn from my mistakes. I hope you enjoyed the video, like and subscribe to the channel, and I hope I see you on the next one. Bye.
Now, after we finished with everything, the most important thing that you never forget when you're building an engine alone and you are not a professional engine builder, you have to write on the pistons, do not blow up. So now we are sure that the engine is going to be okay.